So we went over simplifying expressions, the rational expressions. Now we're going to go into multiplying rational expressions. So I'm going to just do the notes part. The homework will be next week. So if you look here, it's really important that you understand the difference between a monomial and a binomial or a trinomial. So anytime you are dealing with a monomial, and again, it's only if they are monomials, then you can just multiply them straight across and then simplify them using any of your exponent rules, such as quotient rule, or any rule that we have been using. So in this case, it's quotient because we're dividing. Now, when you're dealing with binomials or trinomials, they're going to ask you to factor everything you can first and then simplify by canceling stuff out and or using the rules again from the exponents. So if you look at the example number 1, this right here, that is one term because there's no plus or minus separating them. Again, you have one term, and one term. So all of these are monomials. So because on example 1, we have monomial, that means that you're going to go ahead and multiply everything together. Okay, so I'm going to go ahead and multiply. But now if you realize, because this is multiplication, this is your product rule, which means that your exponents, these will be adding together because it's the same base. So I'm going to have 10a to the 5th power because I added them, b to the 2nd power, so let me rewrite that, and then c to the 2nd power, and then d. At the bottom, I'm going to have 20, because 4 times 5, a, b to the 2nd power, c, and d. So now, if you look at this, these are all being multiplied. I had to do the product rule. So first of all, I'm going to simplify the 10 and the 20. So that's going to turn into a 1. That's going to turn into a 2. Now, the 5, that a to the 5th power and a to the 1st power, which is technically what these all are. Remember, these are quotient rules, so you're going to be dividing. So I'm going to go ahead and rewrite it again. So I'm going to be left with a to the 5th power. It's at the top, which means I'm going to leave it at the top because it's bigger. So a to the 5th power minus the 1 is a to the 4th power. Now the b's. The b squared is the same as the b squared at the bottom, which is going to be b squared minus 2 is just 0. And remember that b to the 0 power is just 1. So I don't need that. C squared is bigger than c to the 1st power, so it's going to stay at the top as just c because 2 minus 1. And then we're going to be left with our d to the 1st power minus d to the 1st power, which is going to be d to the 0 power, which again is essentially just 1. So my answer only left at the bottom is a 2. So then this would be my final answer. Now if I look at example 2, this is separated by a plus or minus, plus or minus, plus or minus. So that means I have a binomial, 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 and this is actually a trinomial. Remember, when you have that, you have to factor everything first and then simplify. So x squared minus 16, that's actually x minus 4 and x plus 4. That's one of those special perfect squares minus a perfect square case. At the bottom, I'm going to factor out a 2, so x plus 4. And then over here, I have x plus 4. I can't do anything with it. And then for the trinomial, I can actually factor this one as x plus 4, x plus 4. So now I'm going to go ahead and cancel stuff out. So if you look here, I can cancel out this one and this one. I can cancel x plus 4 again and x plus 4 again. So I essentially have a 1 here. So now I have x minus 4 times the 1. That is just x minus 4. And then you have 2 times the x plus 4. So 2 times the x plus 4. And then you're done. You can't cancel anything out. So these would be your 2 answers. So if we look at the next one, it says find the product and then write your answer in simplest form. Same thing. So you have to determine, okay, are these monomials, binomial, or trinomial? These are all monomials, which means that when that happens, you're just going to multiply straight across like you normally would with fractions. So this is going to give you 3k to the 4th power because I'm adding those exponents. And then I'm going to get 24k. Now simplify your fractions. So I'm going to end up getting 1 here, but I'm going to determine later if I'm going to have to write that one, because sometimes you don't have to. And then we have 8. But then the k, it's bigger at the top, which means that you're going to leave it at the top and subtract the 1 here. So I'm going to be left with k to the 3rd power and 8 at the bottom. You don't need the 1 there, but you can put it if you like, but you don't need it. And then you're done. So that would be your simplest form. Now all of these here, these are all monomials. That's one term, 1, 1, 1. So all you're going to do is multiply them straight across and apply the quotient rule. That's actually what I did here. So quotient rule when you subtract. Okay? Subtract exponents with the same base. So that's what I'm doing. Again, they can only be with that same base. I gave you the answers to these. The monomial should not be that hard, so I'm going to go ahead and move on. Now I'm going to look at this one. Whoops. 5 seems out there. So let's go ahead and try 5. Alright. So first things first, because these are not all monomials, this is a binomial, trinomial, binomial, trinomial, I'm going to go ahead and factor these out. So c squared minus 1, that is a perfect square minus a perfect square. So I can use my shortcut, c minus 1, c plus 1. Okay, factor out a 2, c minus 7. Now let's go factor out the trinomials over here. We're left with negative 21. What times what gives me a negative 21, but also a negative 4. So I'm going to get, whoops, not x, c minus 7, and then c plus 3. Because that gives me negative 21, but when I subtract that, I get a negative 4. And then the last one for the bottom, the trinomial, I'm going to get c plus 3. And c minus 1. That gives me negative 1, but a positive 2. Now I'm going to go ahead and start canceling stuff out. So if you look at this c minus 1, you have it over here as well. So I can cancel them out. If you look at the c minus 7, you have it up here as well. You have a c plus 3 and a c plus 3. Now if you're wondering why I'm canceling these stuff out, as long as they are not next to each other, you can cancel them. So see how c plus 3 and c plus 3, one's on the top, one's at the bottom, you can cancel them out. If it was c plus 3 here and c plus 3 here, you can't cancel them out. They're sideways. You can only cancel out if it's diagonally or up and down. Okay, so that means everything here is technically a 1 and a 1. Anytime it cancels it out, that's what you're turning it into. So you have 1 times c plus 1, which is just c plus 1. And then you have 2 times all of these ones that got changed into that. And then you're left with just 2 as the denominator. And then that would be your final answer. You guys will do the next one. Don't confuse you. I totally forgot that 3 there. So w minus 6. This is what I had. 3w minus 6. These cancel out. Okay, so then you can simplify this one. So I'm left with 4 and then 3w. Yeah. Okay. If you don't want to cancel out the 1 and the or 7 and the 14, that's fine. You would just do 2 times the 14, gives you 28, and then 7 times 3, that gives you 21, and then you would simplify. Okay. So it's going to be the same thing. You get 4 over 3w for number 7. Let's go ahead and move on. I'm going to do some of the other ones that are a little bit more complicated, just so in case you're not sure, I can do some examples. Alright, so I'm going to do 20 next. That's probably the last one I'll do. So for number 20, remember, if they are not all monomials, you're going to have to factor. So if you look here, you're going to have to factor that. However, this does not have a GCF, which means you're going to have to multiply the 3 and the 4 to get you a equals 1. So you're going to be left with y squared minus 7y plus 12. But because you multiplied by 3, you're going to have to divide by 3 eventually. Okay, so then from there, I'm going to go ahead and factor this again, or keep factoring. So I'm going to be left with 4 times 7 I'm sorry, 4 times 3 to give me 12 and also 7. But I need to make it negative. Okay? But remember, because I multiplied by 3, I'm going to have to divide by the 3, which is going to give me y minus 1. And then this one will be 3y minus 4. So now I factored everything for the first part. I was working on that the whole time. So now for the bottom part, I'm going to factor out a 4y. That gives me 3y minus 1. The second part over here, 3y minus 1, I can't do anything with that. But the bottom part, I can factor out a 5y squared. 5y squared. I'm left with 3y. Let me rewrite it because I ran out of room. So I can factor out a 5y squared. I'm left with 3y minus 4. So now I'm going to go ahead and see what can I cancel out. So first of all, I can cancel out the 3y minus 4. I can cancel out the 3y minus 1. And I cannot cancel anything else out. Remember, these all turned into a 1. So you have y minus 1 times the 1s, which is just y minus 1. And then you have 4y times 5y squared, which is going to give me 20y to the third power, because you're going to have to add those two. And you can't cancel these y's by quotient rule, because it's not just a y times a 1, it's a y minus 1. So this is attached, you can't do anything else. So then you would be done for this one. So 20y cubed. And then that's it.